Alright, when we're giving the end behavior on a polynomial, this was chapter 3 material, the end behavior is determined by two things. One of them is the degree, and one of them is the leading coefficient. Okay. If the degree of our polynomial is an odd number, we know that means our ends go in opposite directions. The negative number out in front, we're worried about positive or negative with the leading coefficient. And a negative leading coefficient means as we go to the right, it goes down forever, down to negative infinity. Okay. As we move, if that was a positive number, it would go up, and a negative number means down. So since we go down to the right, and the 3 is odd, it means opposite directions for the left. That's all I needed for 2 points on number 15. Okay. On number 16, algebraically is a word that a lot of you missed, and fewer than half of you gave me the multiplicity of any of the zeros that you found, whether you used algebra or not. Okay. When we are using algebra to do this and not asking a computer to do our thoughts for us, okay, we factor out this polynomial the best we can. So take the greatest common factor out of all of the terms, and then x squared plus 4x plus 4 is x plus 2 quantity squared. Okay, if I want to find the zeros of a polynomial, I set this to equal to 0 and I solve for x. Okay, so I get 0 from right here. I get negative 2 from the other piece. And the negative 2 is multiplicity 2 because it's a 0 twice. If you specified multiplicity 2 on the negative 2 and didn't tell me this was multiplicity 1, I knew that you knew what multiplicity meant. Okay? Typically, if it only happens once, we don't say it out loud. Okay, but we needed to designate that negative 2 is multiplicity 2. Okay? That tells us when we're trying to graph it down here. Okay? If I have a 0 of multiplicity 2, that means it bounces off the axis. And multiplicity 1 means it cuts through. So my two zeros are at 0 and negative 2. We can't really see the graph there, so I'll just make my own marks. Okay. But we know it goes through negative 2, and we know it goes through 0, 0. We know from 0, 0 it goes down. We know from negative 2 it goes up. And we know because of multiplicity 2 at negative 2, it's going to bounce. Okay, maybe I didn't make it bounce high enough, maybe I bounced it too high, but this is the general shape of the graph. Okay, I don't cut through here, I bounce off the axis. Over here at 0 is where I cut through. Okay. I thought I asked, is this, oh, I guess it's a function. I don't know, I didn't ask yes or no, is it a function? But give the domain and range. Okay, the domain of any polynomial, I said this out loud with lines, but I'll say it again so you can hear it over and over again. But the domain of any polynomial is all real numbers. There is not ever a way to make a polynomial undefined. Now, in this case, because the ends go in opposite directions, the range is also all real numbers. It goes down forever, it goes up forever. If the tails were to go in the same direction and both go up or both go down, our range would be restricted, but this one is not. Okay, again, parentheses, that's kind of a mess, but parentheses at both ends. Okay, the negative infinity has to come first, or that's not correct notation.